So, as we progress through this lesson, how does each graph compare to the original? Well, I kind of find that this is a silly question simply because, I don't know, they're just transformed. Like, we've been working on transformations for so long that all we have to do is apply transformations to the parent function, and we can take us definitely a lot of places. So at times, it's important to keep in mind where the parent function, f of x is equal to x, the square root of x, and ask, how is the parent function transformed? Now, this may inform you as to the domain of the radical function. So if I take a look at this, and if I'm going to transform it, my goal is to graph this. Y is equal to 3, square root of negative x minus 2. I would like you to write this in transformed form. That is, write it in the way y is equal to a f b x minus h plus k, if you can. Or, in other words, simply pick out the parameters a, b, h, and k. A is 3. B is negative 1. H is 2. K, well, there is no k. K is 0 here. So I'm going to sketch the graph of each function using transformations. So very nicely, whoever gave you this question also gave you the graph to map. So there we are. We've got a definitely great starting place. And I'm going to select my coordinates that are integers. I'm going to select a whole bunch and to simply to try to make my math easier. So for instance, I'm just going to start off with point y is equal to f of x. Or, you know what, I'm going to try to keep it in regular function form. Y is equal to the square root of x. I have point xy. I'm going to apply my vertical stretch of a factor of 3. And that just really changes y, or I have xy. And I multiply my y values by 3. Be careful that you don't do something silly, that when you're multiplying your y value for this point, 1, 1, that you don't accidentally move your y value to 4. Very common mistake. So 4, 2 turns into 4, 6. 9, 3 turns into 9, 9. Now at any one point I may drop some points here, but I'm keeping all 4. This is looking good. So this is the equation, y is equal to 3 root x. So how did my domain and range switch? So my domain from my original one is 0 to infinity, and my range was 0 to infinity. Well, here, since I vertically stretched, my domain is going to remain the same, so it remains as 0 to infinity. But my range, I multiplied my y values by 3. So it's really, my range changed. I have to multiply my y values. So the endpoint 0, 0 times 3 is still 0. And 3 times infinity is 3 infinity, but we don't say or write that. We just write infinity. All right, good times. Now I'm going to grab orange, and I'm going to, so I did A, and now I'm going to do B. B is negative 1, so 3 times the square root of negative x. I'm going to put x in brackets just to make it easy. And this takes point x comma 3y and maps it into negative x 3y. The y values stay the same, but I have to multiply my x values by negative 1. So this point here, this point right here was 1, 3. It turns into negative 1, 3. This is 4, 6. It turns into negative 4, 6. Now, let me just check. I think right there. Good. And this point here was 9, 9. So I'm going to change it to 9 or negative 9, 9. So I have this function going. Oof, and I just missed it. There we are. I have this function going on. And my domain is switched. How is my domain switched? Now remember, I multiplied my y values by negative x. So I'm going to have to multiply the endpoints of my domain by negative 1. And that turns them around to negative infinity, to 0. And my range will still remain the same. So my range remains unchanged. So far, I've taken care of A. I've taken care of B. Now let's just take care of H. H is equal to 2. Well, H is equal to 2. Now I need to search a color. I'm going to grab this green right here. So if H is equal to 2, that just simply, I'm going to write my functional form just because I need like extra practice, I think. So that's my functional form. Now when H is 2, I simply add 2 to the x coordinates. My y value stays the same. I'm just going to graph this if you don't mind. I'm going to take this point. I'm going to shift it over 2 units. 0, 0 turns to 0.20. Take this point right here and I move it over to 1, 2. So right there. I'm going to take this point, going to shift it over 2 units. Take this point, shift it over 2 units. Now, there's not much math going on in my brain when I'm shifting things over 2 units because I'm on a grid and I just shift it over 2. There. That's looking like a great function, and I think that I have scored this quite well. So I'm just going to lasso this. I'm going to bring it down. Anyways, this final function has a domain. Well, it has the domain as the same one before, but it's shifted over 2 units. So negative infinity plus 2 is negative infinity. 0 is going to be shifted over 2 units, and my range remains the same. All right, I hope that makes sense. Now, I'm just going to maybe just figure out the domain in a different way. Instead of working through all the transformations, let's try to figure out, well, let's look at our radicand. Really, the domain can be figured out where my radicand is greater than or equal to 0, because that is where x is allowed to occur. All other x values that are negative will be excluded when you try to take the square root of a negative number. So really, I just have my radicand is greater than or equal to 0. I'm going to multiply both sides by negative 1. And when you multiply an inequality by negative 1, I would put a star. Should take this down. When you multiply an inequality by negative 1, the inequality sign switches from greater than or equal to less than or equal to. And then I'm just going to add 2 to both sides. We get x is greater than or equal to 2. And wouldn't you know it? That's my domain. Sorry, I lied to you. Ooh, almost made it through the whole video without lying. Anyways, allow me to say that. This is right. So x minus 2 is less than or equal to 0. So I'm going to add 2 to both sides. So x is less than 2. And when you take a look at this domain right here, that exactly describes all values of your x that are less than 2, since this and this are equivalent.